All right, let's get started. So welcome for the first lecture of the annual lecture series of this new year. And it's my great pleasure to introduce today's speaker, Kerry McKenzie, who is an associate professor in the Department of Philosophy at UCSD. She got her PhD at Leeds, working with Stephen French, and she had postdocs at Western and at Calgary before moving to UCSD. Kerry works on many areas of philosophy, but her main focus is work in philosophy of science, philosophy of physics, with an interest in metaphysics, where metaphysics connects with philosophy of physics. She's published widely in the best journals of the field, philosophy of science, BGPS, studies, you name it. And last but not least, Kerry is trying to save us all. Hopefully she'll succeed. She's become the chair of the PSS, Philosophy of Science Association Climate Task Force. And the goal of this recently created task force is to help reduce carbon emission related to philosophy of science in general, but the PSA more specifically. Now that's an important task. It's also a difficult task. So she told me to tell you that if any of you has any good idea with respect to how to save the world, at least in this respect, trying to help us indeed reduce carbon emission. One possibility, of course, is to increase the frequency of Skype talks at the PSA meetings. Not an uncontroversial idea, so maybe some of you may want to talk to her about that kind of idea after, or other ideas. Anyway, thanks for doing that also. That's an important thing. And thanks for coming. And today, Kerry is going to be talking about progress and its problems, coming to terms with theory change and metaphysics of science. Thank you.
Thank you so much. So I should say that last time I was the PSA, I saw one really amazing talk given over Skype by, who were you? You see, the grad student I was having lunch with, this guy, he did an absolutely smoking job, proving what this can be, and especially if you don't want to have to confront the author of the paper you're commenting on is healthy. Possibly in Pittsburgh, while they're sort of flailing around in Vancouver. Today's talk, Progress and Its Problems, coming to terms with theory change in the metaphysics of science. So I should say I've been kind of mucking around with this for a few years, and some of you have seen certainly the first half of this talk before. I'm a little embarrassed about that. But I've actually only just recently started writing it up. The kind of first paper from this just came out a month ago, and I'm still talking about it because I don't know what to say about it. Right? I still don't know what the solution to this problem is. Hopefully not too boring for those of you who've seen at least some of this before. So the questions that are really animating me at the moment are metaphilosophical questions. And in particular the question of what is naturalistic philosophy? When you say you're a naturalist, what is it that you're committing to? And in particular, what is naturalistic metaphysics? This is the question I'm interested in, most of all just because metaphysics is where my background is. Now this question engages a bunch of really kind of central traditional issues in the philosophy of science. So questions of demarcation, right? Naturalistic philosophy is about some special relationship between science and philosophy. You better have some idea of how it is that you characterize each of these if you're going to talk about that. Talk about demarcation quickly gets you enmeshed in questions of progress and what that is, partly because science is often held up to be a kind of field of which progress is a kind of hallmark feature, one of its kind of distinguishing features, and many people would say philosophy not so much. That's one way of cashing out the distinction. And talk about progress very quickly gets you enmeshed in questions about values, right? Progress is a kind of normative concept after all. What is it that we're going for in inquiry? Like what's the end game, right? What's the metric against which, or the end against which progress is going to be measured? Right, so some of you might be able to anticipate, I've been reading a lot of Larry Loudon again, it's been great. So when people try to cash out what naturalistic metaphysics is, you'll often hear people reaching for metaphors of continuity. It's a metaphysics that's continuous with science. Now, I should say that people often talk about metaphysics in this way, metaphysics in general. Non-naturalistic metaphysicians often like to appeal to this kind of Quinian idea that metaphysics is continuous with science, everything's kind of the same ultimately. And I disagree with that about lots of metaphysics. I think it's based on a completely false idea about how theory assessment works in science. But when it comes to what I would call naturalistic metaphysics, I think this metaphor has plenty going for it. So one thing that you might say is that naturalistic metaphysics is epistemically kind of continuous with science, in that it's deeply informed by science, right? What you're doing when you do naturalistic metaphysics is you sort of sit down with a theory, and all my examples will be from physics. I think the morals are going to be very different for philosophy of biology. But in the metaphysics of physics, what you do is you sit down with a physical theory and you ask metaphysical questions of it. And that physical theory is going to inform your answers to those questions, right, throughout your theorizing. So it's epistemologically continuous insofar as it's the starting point, but it also gives rise to a kind of crude but significant form of epistemic continuity in that your metaphysics thereby becomes falsifiable. Right? Certainly your reasons for holding on to a particular metaphysical claim, which are of course part of your metaphysical claim, they're going to stand or fall with the theory. Right? So metaphysics in this sense becomes falsifiable. You can also say that for lots of projects in the metaphysics of physics, there's a kind of axiological continuity between them. Right? They're ultimately interested in doing the same thing. One thing one often hears about physicists and what they want to do, and this sounds a little bit kind of creepy and dated now, but one thing that you would certainly you would hear particle physicists say is that the ultimate goal of physics is to discover a theory of everything, right? A truly fundamental theory from which all other facts about physics may, in probably some idealized sense, be derived, right? That's the ultimate, that's the holy grail of physics. You'll also hear metaphysicians of physics saying the same thing. So here's Chris Vutrick and Thomas Bigash, who introduced their lovely recent compendium of work on the metaphysics of physics by saying metaphysics is a study of the fundamental structure of reality. Right? So all these parties are interested in discovering what's fundamental. Now, of course, the two aren't in competition with one another here, because what the metaphysicians are doing is starting where the physicists leave off. They give us a fundamental theory, and metaphysicians of physics tell us what is fundamental to that theory. So that theory is full of objects, properties, laws, it's full of bits of language like modal language, it's full of things like the direction of time. It will tell us which of these things can be derived and what is really fundamental to this theory. Right? So they're kind of finishing the job started by physics. Okay, so in some of my recent work, I've tried to argue that this constant emphasis on continuity between naturalized metaphysics and physics obscures the existence of certain crucial disanalogies, crucial theoretical disanalogies that exist between metaphysics and physics. And by theoretical disanalogies, I mean disanalogies regarding the nature of the concepts that they use and the nature of the claims that they make. And in a nutshell, the difference is this. Scientific theories admit a hard to characterize, hard to formalize, but nevertheless intuitive notion of approximate truth. However, it seems to be characteristic of at least canonical metaphysical claims that they have a kind of all or nothing character to which the language of approximation is completely inapplicable. They're just true, they're simply true or false, and there's not any obvious room for middle ground between them. Right. So it seems to me that naturalistic metaphysics then faces a problem of theory change that is even more significant, right, even more challenging than that facing science, right? So think about somebody like Larry Loudon, somebody who uses the parade of failed theories against the scientific realist. They say, look at this timeline of theories in physics, you believe one thing, and then you believe something radically different, therefore all there is change at the theoretical level, you can't talk about knowing more, knowing better, you just know something different. And then, of course, the realist comes along and says, no, if you look at these theories and you sort of get rid of these things and you focus on that, you can see that something is preserved, that this old theory can be regarded as approximately true relative to that theory. Okay, this is what they're going to say. This is what the realist is going to try and defend. If, on the other hand, when it comes to metaphysics, there is no such thing as a notion of approximate truth. There can only be theories that change from black into white, as it were, there is no kind of theory change that we recognize other than radical theory change. But of course, if you're a naturalist, then you're open to the possibility and the likelihood that as your physical theories change, which we think they will, your metaphysics is going to change too. Right? So it seems that you're committed to the possibility of radical theory change and you don't have any obvious avenues out. So it seems to me this is a really neglected problem in the metaphysics of science. So why do people not work on this so much? Very explicitly, there's one or two papers, but not much. So one thing you might think is maybe metaphysicians of physics don't really regard metaphysical discourse as sort of on a par with that of scientific discourse. It performs some other function, but it's not sort of truth apt. It's not really there to describe the world or something like this. Of course, Popper thought that, the positivists thought that. That's not what's going on these days, certainly not with the protagonists in the debate that I'm interested in. So, Everything Must Go, Metaphysics Naturalized by James Ladyman and Don Ross has been a foil for lots of my work in metaphysics, and this book opens by saying the following. One of the main contentions of this book is that contemporary analytic metaphysics, a professional activity engaged in by some extremely intelligent and morally serious people, fails to qualify as part of the enlightened pursuit of objective truth and should be discontinued. Right? It's a very natural way of reading that is that our metaphysics, on the other hand, is a contribution to the pursuit of objective truth, and it's hard to read that as saying other than these are truth apt claims themselves. So what it seems to me is really underlying metaphysicians sort of not really worrying about the problem of theory change when it comes to metaphysics is that we seem to be under the impression that once we have sorted out the problem of theory change in science, we have ipso facto sorted it out in the metaphysics of science, just because the metaphysics is so continuous with that science. It's so closely connected to it. So you can find this idea kind of peppered throughout the literature, but the most explicit statement of it is in that same book. So here's what they say. One consequence of naturalism that can't be avoided is that if our current scientific image of the world changes much, as we suppose it will, then it will then turn out that the best current metaphysics is substantially wrong. Neither we nor anyone else can do better than articulate the best metaphysical picture the current evidence suggests in attempting to sketch the image of the world that science presents to us now. We look forward to future science proving us wrong, but hope that philosophers armed with current science will have trouble doing so. Note that to the extent that metaphysics is closely motivated by science, we should expect to make progress in metaphysics, if and only if we can expect to make progress in science. In Chapter 2, we indicate at length why we hold fallibilism about science to be compatible with optimism about epistemic progress in science. This argument carries directly over to scientifically motivated metaphysics. Right? So the idea seems to be that if your science is making progress, and your metaphysics is very closely coupled to that science, then the metaphysics is going to be dragged along with you. Right? And it seems to me that that inference can't go through. Right? If that's the right way of reading that, I don't see how that's going to work. Precisely because the kind of progress, the notions of progress that are applicable to science don't seem to be applicable to metaphysics. Okay, that's what I want to argue. So what I'll do today is I'll very, very briefly discuss, and I'm going to assume most of this is familiar to most of you, how those optimistic about the prospects of scientific realism have responded to the problem of theory change in physics, and emphasizing that in physics, at least, it is the existence of what are called relations of correspondence between successive theories that's taken to facilitate some notion of approximate truth and hence of epistemic progress. Right? I won't say too much about that. I hope it's familiar to lots of you, but I will say a bit about, just note that if physics does indeed progress in that way, then it's an incredibly significant form of progress. Right? We talk of progress when we have much, much less than this. Or we're happy to. I'll then contrast that case with the theory change in metaphysics, in which I will argue there's no sense there to better approximations to the truth, and so seemingly all theory change is radical theory change. And to make my point, I will sort of use the examples of ontic structural realism and humanism as my examples of what I mean by canonical metaphysical claims. Now, I'll say a bit about why I've chosen these. Now, as I was talking about with John earlier, it's not the case that every project in the metaphysics of physics is going to be vulnerable to my criticisms. but a lot of showcase metaphysics and physics is, right? And I think it's an interesting question about how it is that we demarcate between these two. I think it's actually which projects are legitimate, which projects are safe from theory change and which projects aren't, which is actually where my own project is going. But these are two very central issues in the metaphysics of science, metaphysics of physics, and I'll use them as my examples. So it seems to me that just as the problem of radical theory change posed a question to the value of scientific inquiry, the instrumentalists would say, well, the value of accompanies our scientific theories as an instrumental value. There's no real epistemic value to it. Given that in metaphysics we don't obviously have that instrumental value, there's a real question about what the value of metaphysical speculation is prior to the construction of a fundamental theory that we don't think is going to change. Okay, so what I want to move on from there, that was all in the last paper. I want to sort of raise a couple of responses, and there's been lots of responses that I've received to this argument. One thing I want to say is that really what this argument does is just show that metaphysics and physics are so different that you shouldn't understand this claim that metaphysics doesn't make progress like physics does as any kind of criticism of metaphysics, right? It's just a different animal, it has different standards, and we'll see as we go reasons to think that, yeah, the two are really fundamentally different. What I want to say is that's right, but it doesn't help with the problem of theory change. I don't see how it makes it magically go away. I'll then say that perhaps I've misdiagnosed the problem. The problem isn't that metaphysical claims in principle cannot approximate one another or can't be approximately true, but what their truth value is highly unstable under small perturbations of the subject matter, right? You change the physics just a little bit and your metaphysics can get radically different. Okay, so if anything, this makes the problem worse because it means that metaphysics might be vulnerable to a problem of theory change even if the next stage of physics is somehow incremental, right, relative to what we have just now. So these are critical points, but the reason I'm mentioning them is that I think they start to shed light on what some kind of solution to the problem might be. Maybe we can talk about that in Q&A. Okay, so start by talking a bit about progress in physics. So you know, here's some of the timeline of the kind of a hit parade of modern physics. We've gone from classical mechanics through to quantum field theory. We've gone from old theories of gravity to general relativity, and we're on the path, we hope, to coming up with a theory of quantum gravity. Now, these are very impressive theories. The realist wants to interpret this temporal sequence, you know, in normative terms as some kind of arc of epistemic progress. So what the realist is going to want is that we can interpret the historical progress of the mature sciences as a matter of successively more accurate approximations to the truth about both observable and unobservable phenomena. Right? Later theories typically build upon the observational and theoretical knowledge embodied in previous theories. Right? This is a picture of accumulation. And continuous epistemic accumulation. Now, as I'm sure you know, this vision was challenged by Loudon in 1981, among others. His criticism was that approximate truth requires reference, right? You can't say that, I don't know, the genetic theory is approximately true if it turns out there are no genes. But it turns out, according to general relativity, there's no such thing as Newtonian forces. According to quantum field theory, there's no such thing as classical particles. So how can it be that we can see these in a relation of approximate truth? Approximately true relative to one another. So people hit back. In fact, they'd hit back before this, but Worrell really drove the point home. Talking about this is a necessary condition on approximate truth neglects some features that are special about the mathematical languages in which theories of physics are couched. And in particular, it neglects the remarkable continuity that we see in physics at the level of the central equations of these theories. So what Worrell's structural realist response does, it appeals to what Heinz Post in his paper Correspondence, Invariance and Heuristics referred to as the generalized correspondence principle. This is the principle that the idea that the central equations of earlier theories are generically retained as approximations to those of the later theory in the domains in which the old theory was empirically well confirmed. Can I use a pen here? Yeah. Okay, so the basic idea here is, take, for example, a bunch of different scales. Maybe this is a temporal scale, this is a spatial scale, this is like very small, very large, very short, very long-lived. This is, let's say, the domain of relatively quotidian phenomena, right? The sort of thing that supported classical mechanics, ships and shores and comets and cannonballs and the like. The idea is that although we think classical mechanics is false because it was superseded by a theory a different theory that has, on the face of it, a very different set of equations at the heart of it. If you examine those equations in the limits that their parameters, say their spatial and temporal parameters, take us back to that set of relatively quotidian phenomena, you will see that actually the equations become very well matched. One becomes a very close approximation of the other. Okay, so long as these relations of correspondence, which as it stands are pretty formally defined, so long as they can be interpreted as having realist import, there's hope that successive theories in physics may be interpreted as better approximations to the truth. Okay, so the classic example here is the relationship between Galilean kinematics, which is the heart of Newtonian or classical mechanics, according to which time flows equably for all observers. Two people in motion with one another won't disagree about how long an event lasts. Of course, this is denied in special relativity, when two observers will start to disagree with one another about how long a certain event lasts, with a function as a function of the relative velocity. So this expression here really doesn't look like that at all, but examine it in the limit in which the velocities become really even just pretty small compared to the speed of light, and you'll get back something that very closely approximates what you had before, right? Heinz-Post says that special relativity is a new, larger, better theory, which degenerates into the old theories in certain classes of cases. Right? It's a larger theory because it describes distance moving very fast as well as pretty slowly. It's a better theory, not only because it describes more, but because it gives us relativistic corrections to the phenomena that we thought we understood. We now have like a 6 decimal place or 7, 8 decimal place kind of characterization of what's going on. So this is what correspondence is all about. Now I should say that I don't like, people talk about degeneration in these contexts. I don't like the term. It's a horrible term. Jeff Barrett has this phrase, descriptive nesting. That's a nicer way to characterize what's going on. The elegance of what's going on. You take this expression here, you look at it, you think about it in a certain limit, and you just literally see the thing deforming in your mind's eye back to what you started with. So it's a really beautiful relation. Okay, and now there's a hope that this is going to work, not just for like this one transition here or something, but it's going to work across the board. Okay, so as Paul says, right, this is going on. These relations appear, this fact appears trivial to scientists, but they don't fit trivially into many present philosophies of science. And here he's kind of talking about sort of a Kuhnian kind of relativism or anti-realism. But of course, people do disagree about the significance and indeed the fact of correspondence. So as you can imagine, Van Frassen is going to claim that there's nothing in here that the empiricists can't help themselves to, right? They needn't have any realists, there needn't be any kind of realist reverberation from these facts. The late great Peter Howson has claimed actually that correspondence is not as pervasive as being maintained. Right? You can regard a Poisson bracket, say, as a limit of the kind of commutators that you get in quantum mechanics. I'm not going to get into the kind of whether the correspondence does have this realist significance, because it seems to me that Jeff Barrett is right when he says that there be a descriptive nesting relation is a precondition for understanding the next generation of theories as refinements of our current theories. Right? The central equations of physics are like the Lakatoshian hardcore of a theory. Right? There's no way that unless you have relations of correspondence at that level, that you can talk about approximate truth in physics. Okay? So whatever approximate truth in physics ultimately consists of, it's got to have this somehow at the heart of it. Okay. So what I want to say now is that if physics does progress by creating theories that stand in correspondence relationships, this confers a very clear sense of value on the activities of contemporary physicists, given their aims to produce a truly fundamental theory. Now, that's not the aim of all physicists, of course, but it's sort of the ultimate aim of physics. So to see this, take seriously the kind of metaphors of preservation and continuity that people always reach for when they talk about correspondence. So Popper did this. I'll just read out Post. My claim here is not merely that there's an element of continuity in change, which is necessarily the case in all human activity, but that in science, part of the content of the old theory is preserved, as far as one can tell, forever, not just in the next theory, but in all future theories. Okay? So really what this means is that, say this is the theory that we have just now, a theory that describes this sort of subset of phenomena. Ultimately, if we want a theory of everything, we want a theory that's going to describe all of this stuff. Now, we don't have that, but we do have this. And we know that the fundamental, if correspondence is true, as a fact, we know that when we examine the fundamental theory in the limit that takes us back to this, then we get something that looks like the theories that we already have. We already know about a sector of this theory. We know what it looks like to a good approximation. We already have a part of what we want. Okay? So this, I think, means that the kind of progress that we get in physics, if this is how it indeed progresses, is incredibly significant. Right? We're happy to talk of progress when we have much less than this. So to see this, compare two situations. Right? Suppose that you have the goal of being in California. Right? Perhaps to enjoy certain political protections. And you are hacking your way across the desert to get there. And of course, we know that there's people doing this every day. Suppose you get 2/3 of the way there. Right? You find a phone box, you phone home. You say, we're making progress, we're 2/3 of the way there. Right? We're getting closer. You get to the border and you meet a border agent that says, sorry, we don't recognize your status anymore, you're not getting in. Which also happens every day. So you can imagine what you would say in that situation. Right? I got so near, but I'm so far. I end up ultimately with nothing. For all that I said, I made progress along the way. Now compare that with another situation in which, say you are climbing up Mount Whitney with the aim, which is the tallest mountain in California, with the aim of making a survey. You're a cartographer and you want to make a survey of the whole of the state of California. Like, suppose you can see the whole thing from the top. So you go up the mountain making your survey as you go, and then 2/3 of the way up, you break your ankle and you have to come home. So that's a situation in which you don't get everything that you want, but you get a part of what you want, right? Your ambitions were frustrated, but you still come away with a big part of what it is you were after. Now, progress in the first sense is a kind of threshold effect. You make progress insofar as necessary conditions for the fulfillment of your aim were achieved, were satisfied. But unless you get everything, you end up with nothing. Right? It's a threshold effect. Progress in the former sense is kind of monotonic. You're steadily accumulating what you want. And it's progress in that monotonic sense that we get if physics progresses by correspondence. And I think if both of us, if we could choose, we would go for progress in the monotonic sense, right? We might never get that fundamental theory after all. Another thing I want to say is that progress by correspondence is really, it gives us a significant form of progress because it's two-dimensional, right? It tells us about more systems, right? Theories that stand in relations of correspondence describe more, but they also describe the old stuff better than the previous one, right? They describe it more accurately. We would talk about progress if we had just one of these dimensions, but instead we have two. And here I can't help but quote from Einstein. When he was talking about theory change, he says this. To use a comparison, we could say that creating a new theory is not like destroying an old barn and erecting a skyscraper in its place. It's rather like climbing a mountain, gaining new and wider views, discovering unexpected connections between our starting point and its rich environment. But the point from which we started out still exists and can be seen, although it appears smaller and forms a tiny part of our broad view gained by the mastery of the obstacles on our adventurous way up. Right? This sounds like very positive way of talking about progress in physics, but we have more than this, because of course as you go up a mountain, you can still see what you could see at the bottom, but you don't see it better than you saw it before, right? You see it worse than you saw it before. So actually the kind of progress that we get in physics, if it is by correspondence, is really significant for all sorts of reasons, right? We're happy to talk of progress when we have a hell of a lot less than this. So, imposing this as a standard of progress on any field is probably too much to ask. Science is perhaps even physics is very unusual, and the sciences in general very unusual in that we can achieve this. Now what I would argue now is that metaphysics is based on that science certainly cannot achieve that. And it almost can't achieve it sort of a priori. Okay, so recall that I gave you the picture of naturalized metaphysics as a project that kind of finishes the job of physics. Physics ultimately is going to give us a fundamental theory. We hope what naturalistic metaphysicians do is tell us what is fundamental to that theory. And of course they'll do that with a non-fundamental theory. People like me go around arguing about what's fundamental in QFT, right? Assuming that theory is fundamental. It's the most fundamental theory that we have after all. Now, again, I think there's a big question here hanging over this. Like, what projects in the metaphysics of physics are affected by my argument and which ones aren't? And I haven't attempted to demarcate this here. But one thing we can say is that the questions that I've been focusing on, right, in my kind of critical, this kind of critical discussion, this kind of attack on metaphysics, if you like, fit the framework of metaphysical projects that are all about identifying the fundamental ontology of a theory and the fundamental ideology of a theory. So these are terms that go back to Quine. It says, well, the ontological commitments of a theory are the entities it posits. A theory's ideological commitments are the primitive concepts that it involves. Okay, so here's the two projects in naturalistic metaphysics I'll discuss. One fits each of these projects. So, or as an example of each. So, ontic structural realism, which is the metaphysical position that is defended at length and everything must go. This is a project in fundamental ontology. It's identifying which ontological categories are fundamental. Spoiler, the category of structure, not the category of objects. It's a question about what stuff is fundamental. The project of arguments over modal metaphysics and whether modality is fundamental, which are really at the heart, I think, of the metaphysics of science. These are standardly conceived as debates over fundamental ideology. Not necessarily what stuff is fundamental, but what language, right? What concepts can be reduced. So, physicists talk in physics is full of modal predications. What's not possible for an electron to do, what's necessary for electrons. The question that Humeans tend to ask is, can this reference to possibility and necessity be kind of analysed away, understood in terms that don't refer to necessity, rather than stuff? Okay, that's the most natural way to construe this. So you might say also things like maybe the direction of time is a kind of structural feature of your theory rather than something that you want to put in an ontological category. Right, so the question would be, can that aspect of your theoretical structure, can that be reduced to something sort of non-directional? Okay, so these are the examples that I'm going to take as my exemplars of naturalistic metaphysics. Certainly they're regarded as perhaps not representative of all claims of metaphysics of science, but certainly pretty canonical claims. My claim is that neither of these metaphysical theses could be regarded as approximately true. So this gives rise to the problem, given that we think the metaphysics is going to change in the future, that there can only be radical theory change in metaphysics, so why don't we worry about it from a realist point of view? Okay? So we think the metaphysics, for example, of quantum mechanics is radically different from that of classical mechanics. Arguably, the metaphysics of quantum field theory is radically different from that in quantum mechanics. We expect there to be radical changes again. Okay, so let's start off with the claim of ontic structural realism. This is the claim that relational structure is ontologically fundamental and individual objects are not. It's a claim about categories. It's a claim that objects are at best a derivative category. They're somehow ontologically parasitic on relational structures. Now, I would interpret this claim as that fundamentally there are no intrinsic properties. Everything that you think of as an intrinsic property of an electron, its mass, its charge, and spin, for example, turns out to be either an extrinsic feature, something that depends on something else, or analyzable as a relation. Okay. Now, to cut a long story short, to give a quick and dirty argument for why that is, in the paper that coins the term structural realism, which is by Grover Maxwell in 1971, structure is defined as whatever is not intrinsic. Okay? So if you're going to say structure is fundamental and objects are not, it better not be the case that there's any intrinsic properties in their structure. Okay, so we'll take ourselves to establish ontic structural realism if we can show that fundamentally there's no intrinsic properties. Now this is a big ask. As Alexander Bird writes, it's very rare for people to suggest that properties like charge, rest mass, and spin are not intrinsic. But this is exactly what structuralists have denied, and in my former incarnation as a structural realist, I would have challenged this. I mean, I've written stuff challenging this. And so here in rough outline was my argument. Take the mass of a field associated with a field in quantum field theory. It turns out that the mass associated with any given field is a function of the energy scale that you're measuring it at. But it also turns out that what that value is at that scale is also a function of the other fields that you have in your theory. And it turns out if you chuck too many fields into your theory, then the mass ceases to be well defined. To me suggests that mass is not an intrinsic property in quantum field theory, because an intrinsic property is one an object has solely in virtue of how it is, totally independently of its surroundings. Right? That characterization doesn't seem to fit with mass in quantum field theory. Now that's just, one can make a similar argument for charge. Glossing over a bunch of subtleties here. Suppose it's true, right, that really quantum field theory does support ontic structural realism, because according to quantum field theory, fundamentally there are no intrinsic properties, right? The problem is, of course, that we expect quantum field theory is not a truly fundamental framework for physics. It doesn't include gravity. And we expect it to be superseded by a different theory, moreover one that thinks about the fundamental very differently. So for example, the way that you kind of inspect the fundamental according to quantum field theory is you look at how it behaves in an arbitrarily large energy limit, right? The reason for that is that quantum field theory describes Minkowski spacetime and goings on. Minkowski spacetime is continuous, so it boils down into regions of arbitrarily small size. More and more energy is needed to kind of probe those regions, right? You have to run your accelerator really fast to look at really small stuff. So given that there's no space bottoms out to measure zero regions, your energies can get as large, arbitrarily large. So it's by looking at what happens in that arbitrarily large energy limit, that's how we look at what's fundamental in quantum field theory. According to most theories of quantum gravity, or certainly many of them, actually space-time is discrete fundamentally. There's a kind of chunkiness to it at the Planck scale. So that limit doesn't even exist. Right? And take my word for it when I say that the demands that are placed on you by finding an infinite limit of a theory, right, really constrain the modal structure, really constrains what things are able to do, and helps you to make some really interesting metaphysical claims. Maybe you can't make them anymore. Now, of course, we know that as a naturalist, you have to be open to your metaphysics being different in that theory. Right? I have to be open to that as a naturalist. So what's the value of, given that you think it's going to change, why bother arguing about it just now? Well, maybe you can do what, the idea here is, that I think is motivating a lot of metaphysicians and physics have in their head, is that metaphysics is just like science, it's progressing in the same way. These claims are somehow approximately true, just as the science is, right? So this is a question, can this metaphysical claim be regarded as approximately true? Well, let's think about that. The claim is that fundamentally there's no intrinsic properties. Equivalently, you can say this is the claim that all the fundamental properties are extrinsic, right? The reason for that is that extrinsic properties are just defined as those that are not intrinsic, right? This is a perfectly standard characterization. So those claims are equivalent. So to think of an approximation to structuralist metaphysics, you need to say something like either approximately all of the properties are extrinsic, you just have one or two intrinsic ones maybe, or the properties are somehow approximately extrinsic. Right, the question is, can you make sense of that? Try with approximately all, first of all. Right, so just to start by noting that as a matter of descriptive fact, no critic of structuralism is going to buy this, right? So as Anjan Chakrabarty, who's been one of the most incisive critics of structuralist metaphysics, has said, in order for the appeal to extrinsic properties to offer any support to ontic structural realism, it should be the case that not just some, but all of the essential properties of particles described by quantum theory are extrinsic. Similarly, Philip Berghofer, who wrote a reply to my paper, in the paper he argued there's at least one property that isn't touched by Mackenzie's argument, the vacuum expectation value of the Higgs field, right? Therefore, ontic structuralism is dead, because to refute, right, these distinctions among forms of structuralism get increasingly baroque, but let's just say, to refute ontic structural realism, it, of course, suffices to identify just one intrinsic property at the most fundamental level, i.e. to show there is one intrinsic property exhibited by quantum fields, right? And it's clear why that is. Structural realism is making a claim about categories. What categories are fundamental? If you have one thing that doesn't fit in the category of structure, that belongs in the category of objects, you have the category of objects. It doesn't matter if you have one thing or if you have a million such things. The category is there at the fundamental level. Okay? So this route is not going to work for you. Suppose we try saying something else. Could we say that the properties are involved are approximately extrinsic somehow. Right, so this is a little bit of a hatchet job, but let me say this. When we say that something is approximately some way, most of the time what we mean is that that thing is at best approximately that way. Right? It's not that way, strictly speaking. Now, maybe that's not the case for like the train timetable or something, but it would be the case here when you have every reason to think that you're wrong in some respect or other. There's some one property that's at best approximately extrinsic, right? So here, when you say that a property is approximately extrinsic, really what you're committed to is it's not really extrinsic. It's something close to extrinsic, but not extrinsic per se. However, you're pretty limited in your options here because as soon as you say that a property is not extrinsic, you're committed to the idea that it's intrinsic. Right? Extrinsic properties are those which are not intrinsic. Intrinsic properties are those which are not extrinsic. Right? Right? This is a pretty generic phenomenon of metaphysics. We'll see more examples in a moment. Metaphysics tends to define its properties in mutually exclusive and jointly complete pairs. Right? In terms of these really dichotomous categories. The minute you say it's not in this category, you find yourself in the opposite category. Okay, can I ask what time it is, by the way, because I don't have a clock here.
It's 4:15.
4:15. Okay, good. So I'll just go through this. I'll go through this very quickly. We can say exactly the same thing at work in the metaphysics of Humeanism. I'm hoping this is something familiar to you, the notion of Humean supervenience. I'm just going to read out a little bit of how Barry Lower characterizes the Humeans' commitments. He says, contemporary Humeans hold that the totality of the world consists of a mosaic of fundamental categorical properties instantiated throughout space-time, right? The Humean mosaic. Categorical properties are properties whose instantiation in a region of space-time doesn't necessitate anything about property instantiations in wholly distinct regions. Humeans claim there is no fundamental necessity in nature connecting spatio-temporally non-overlapping events in non-overlapping portions of space-time. In contrast, non-Humeans think that there is fundamental necessity in nature. Some non-Humeans hold that nomological necessity resides in the properties themselves. They thus deny that all fundamental properties are categorical. At least some properties are claimed to be such that it follows from the natures that if something happens over here, something happens over there. Other non-Humeans hold that laws are themselves fundamental features of reality. Okay, this is a picture of Humeanism. Can you approximate this picture? Well, it all turns on your notion of a categorical property, right? This is standardly defined, and we don't really define these because you kind of can't, but the idea behind them is they're a property with no essential or other non-trivial modal character. Okay, they're properties such that you don't need any recourse to modal operators to define them. So the Humeans' claim is fundamentally all properties are categorical. Can you approximate that claim? Well, you play the same game. It's unclear what an approximation to that could mean, that other than either approximately all properties are categorical, you just have one or two non-categorical properties, or the properties are approximately categorical. If you go the first route, you say there's just one or two categorical properties, then you're dead, because you have some properties that require recourse to modal, like dispositions and so on, that require recourse to modal language to articulate them. So you need those operators in your theory, so that language cannot be analyzed away. Okay? What about if you said, well, the properties are approximately categorical? Again, what does that mean? What is it? If a categorical property is a property with no essential or other non-trivial modal character, then a property that lacks that has some essential or non-trivial modal character, and hence you need those operators to define it. Either way, there's no sense in which this claim can be. The flagship claim of Humean metaphysics can be regarded as approximately true. So it seems to me there's no clear sense in which the claims of metaphysics, this kind of metaphysics in particular, can be said to be approximate, this fundamental ontology, fundamental ideology thing, can be said to be approximately true. Metaphysical claims seem to have a kind of clunky, all-or-nothing character. Slight departures from exactness flip them into exactly what it was they wanted to avoid. So, I read somewhat recently Nicholas Rescher's book, The Strife of Systems, very interesting book of metaphilosophy, and this kind of reconfirmed what I thought. So there he talks about how philosophical positions quite generally are based on deliberately conflicting visions of things. There's just no way to have it both ways. To deprive them of their contrariety is to deprive them of their substance. Where there's no enemy to attack, there's no position to defend. Right? But having it both ways is a good way of talking about approximation. You were kind of right, but you were kind of wrong. Right? You can't have that here. So, as I've said, however, this circumstance raises questions about what the value is of engaging in metaphysical speculation today. So, to try to build up to what that value might be, and there's lots of things you could say here, I just want to mention briefly a couple of responses that I've had to this argument. Here's one. Really what this argument has done, by pressing all these disanalogies, we've shown that metaphysics and physics are importantly different. And actually there's something implicit in what I've said that points to the idea that they are not subject to the same rules, and in fact that they have different aims. And so, of course, the same notion of progress can't apply to both of them. If you have different aims, the notion of your sense of progress is going to be different. Okay? So, about the two forms of theorizing being subject to different rules. Given that we can see from the fact that metaphysical concepts tend to have this dichotomous character, that metaphysics isn't bound to employing only natural properties, right, in its fundamental properties, right, in the fundamental predicates of its theory. So remember what Lewis said about natural properties. If you have a natural property, like, say, being red, then the negation of that property is not a natural property. It's gerrymandered, right? It's not eligible in your metaphysics, you shouldn't have it in your theory, right? He had all sorts of arguments for that. Given that the properties of metaphysics are defined in these mutually exclusive, jointly complete pairs, they have one property and the negation, and they're both parts of metaphysical language, clearly metaphysics is not bound by that rule, right? So different rules apply. Now, we can see why this, you can also think about that's not ad hoc. It's appropriate. Why? Because it's pretty clear, right, that really metaphysicians are actually aiming at a kind of generality and abstractness that physicists are not. Physicists want to tell us what the fundamental laws are, metaphysicians want to tell us what is a law, in general, as a category. Right, as Adrian Moore says in his monumental book, The Evolution of Modern Metaphysics, he tries to look at all of it, and the best way he can summarize everything we call metaphysics is, metaphysics is the most general attempt to make sense of things. So what that means is, and so that we can see from this that why it's okay for metaphysicians to not be bound by the rules that govern natural properties. Take that gerrymandered set, right, that Lewis would say you can't have in your metaphysics. Because it's gerrymandered, right? Blue is unlike yellow, is unlike green. All these things are not red. They're all the same from the point of view of metaphysics. They're all colours, right? So at the level of abstraction at which they're working, those differences that make the set gerrymandered cannot be seen. So this tells us that really progress in metaphysics can be like that in physics. They have different aims. Think about how physics progresses. Physics progresses by discovering detail. Right, we're going to make progress in, say, quantum field theory when we can take two beyond the standard model theories, each of which is sort of tailored to give the same predictions of like 7 TeVs, or whatever the energy of the CERN is these days. But they're going to say different things about what happens at smaller scales. And progress is going to be made when we find out which one of these gets the details right and which one of them gets them wrong. Metaphysicians, by contrast, want to wash many of these details away. Whatever the sense of progress is in metaphysics, it just can't be like that in physics because they have different aims in life. Okay? Now, I think all of that is absolutely fine, and it might even be quite insightful. The problem is I don't see how it helps with the problem of theory change. I can give you an abstract description, and I still can know that it's going to be wrong in the next theory, so what's the value of it just now? It's a puzzle. Okay. Second and last response. And this is very much work in progress. You might say I've misidentified the problem. The problem with metaphysics is not that its claims are resistant to approximation, because there are scientific claims that have an all or nothing character that we think are here to stay and we're not worried about. So there's no problem of theory change for them. Really, what the problem is with metaphysics is that the characteristic claims of at least some naturalized metaphysics are unstable even under small perturbations of the underlying physical theories. In a nutshell, the metaphysics of approximately classical physics is not an approximation to the metaphysics of classical physics. And that might even be the case, even if you could talk about, in principle, approximations to metaphysics. In fact, those approximations are not borne out. So here's an example. I've been reading this lovely book, The Stability of Matter by Elliot Leib and Robert Seiringer. The whole point of this book is to discuss the answer to the fundamental puzzle, right, that we faced at the moment that somebody came up with the theory of quantum mechanics, which is that when you have a positively charged nucleus and a negatively charged electron circling around, why doesn't the electron circle into the nucleus, right? Classical mechanics says it should. It doesn't do that. It should do that, given that you have these charged particles rotating around each other. So why doesn't that happen? Why, in other words, do atoms take up space? Why don't they just collapse into one another? Right? Why is there like a finite diameter to matter? Why does it take up space? Right? These different questions of stability, but this is the first one. Why don't the point-like electrons fall into the nearly point-like nucleus? This is a question that has a kind of dichotomous character. Because really what the question is why is the energy of such a system just not arbitrarily negative? That's all it is. Right? Why don't these things just collapse into one another? Why does matter take up space? Why does it have a kind of spatial temporal stability to it? It turns out that's just the question of why is the energy of the system not arbitrarily negative? Here's what they say on the first page. Despite the great success of quantum mechanics in explaining details of the structure of atoms, molecules, and macroscopic objects like transistors, it took 41 years before the most fundamental question of all was resolved, by Dyson, actually. Why doesn't the collection of negatively charged electrons and positively charged nuclei, which are the basic constituents of the theory, implode into a minuscule mass of amorphous matter thousands of times denser than the material normally seen in our world? Even today, hardly any physics textbook discusses or even raises the question, although the basic question of stability is subtle and not easily derived using the elementary means available to the usual physics student. There is a tendency among many physicists to regard this type of question as uninteresting because it is not easily reducible to a quantitative one. Matter is either stable or it is not. Since nature tells us that it be so, there's no question to be answered. Right? Nevertheless, you say it's a fundamental question we need an answer to. Right? So this question, like, is matter stable or not, has a kind of dichotomous character. Right? Is the energy associated with it finite instead of arbitrarily negative? Well, as we show in the book, you can establish that it is. Matter is stable, after all, by deriving inequalities on the kinetic and potential energies. You show that the potential energy can't go below this, the kinetic energy can't go below that, therefore above that, so that way you have a stable system, right? You derive some inequalities that show that. Now, since quantum mechanics, we believe, is a limit of a relativistic theory, it seems to me you can assume that those inequalities are approximately correct. Right? The equations of relativistic quantum mechanics are going to converge on those of quantum field theory as applies to those atomic systems. They're going to offer little corrections, but that isn't going to change the fact that these equalities are roughly correct, and that's what we need. And so, this is a dichotomous claim, a claim about stability that is here to stay. The problem then can be that it's failure to approximate per se that causes the problem of theory change for metaphysics. The problem is rather that the truth value of a metaphysical claim is unstable even under small perturbations of the underlying theory. Right? And this will mean that metaphysics faces problems even if future theory change is in some sense only incremental. Right? And I'm going to make this point, this is where my work is going just now, I'll try and make this just make it a little intuitive. Many of the classic metaphysical differences between quantum and classical mechanics show up even in regimes where the two theories we think mesh very nicely with one another, right? Even in the kind of domain of close correspondence. So for example, these are some patterns of particle tracks coming out of a cloud chamber. These particle tracks look very much like what Newtonian mechanics would predict, for a particle, oops, that was not right. For a particle, that starts out here, Newtonian mechanics is going to predict, with its position of momentum, is going to predict kind of very roughly where the particle will end up according to quantum mechanics. Okay? So this is an area where quantum mechanics and classical mechanics are really nicely meshing. It's not like some really short time scale where they just like radically diverge from one another about what we say. However, Schrödinger, who of course understood these particle tracks very well, argued that So these particle tracks, we're interpreting them as some continuous particle, like persisting through them. Schrödinger knew you can't interpret it that way. The series of position eigenstates occupied by that particle is going to be discrete. They might be separated by very small distances compared to every other scale in the problem, but it is discrete. Right? Schrödinger always thought that the lack of spatio-temporal continuity, right, exhibited by quantum systems, the fact they don't have classical-like continuous trajectories, meant the category of objects had to be abandoned because there's no longer any unambiguous sense to diaphonic identity. For any position eigenstate, it could be the particle that started here that's occupying it, but with a lower probability, it could be one that started further away. So he said to be an object is to be the kind of thing, an object distinct from an event, it's the kind of thing that persists through time. You can't talk about that anymore. So what we see then is that even though here classical mechanics and quantum mechanics are a very close approximation to one another, the metaphysics is radically different. Here, arguably, you don't have the concept of objects anymore. Okay? So an approximation, the metaphysics of approximately classical physics is not an approximation to the metaphysics of classical physics. So what do we see? Conclusion. Whatever's going on in naturalized metaphysics, it does not progress like science does. That in itself is not a criticism. They're different animals and they have different aims, but I don't see a way around the problem of theory change. Indeed, there might be an even worse problem of theory change for metaphysics, because even if future change is only incremental in some sense, we still have a problem of radical metaphysical discontinuity. So here's a question: how does naturalistic metaphysics progress, if not at all? So this is really what I'm thinking about, and I don't know what the answer is. Naturalistic metaphysics is weird because it's kind of neither fish nor fowl. It's a philosophical position. It's not science. It doesn't use scientific language so much. It's not all the discontinuities, the disanalogies between the two fields convince me naturalized metaphysics is not science. It's something else. But it also doesn't seem to be like other bits of philosophy. Like when people talk about how philosophy has progressed, obviously it's not that there's no longer any Aristotelians, it's that Aristotelianism has progressed in ethics. Say. We have a better understanding of what Aristotelian virtue ethics is. We have a better understanding of what utilitarianism is, even if there's still plenty of people that think it's wrong. So philosophical positions kind of progress by kind of better articulating their own internal logic. Naturalized metaphysics is too coupled to things that exist outside of itself for that to be the right characterization of it. It's not this inward-looking thing. And it seems to me it's coupled to something that undermines it. It's neither fish nor fowl. It's tempting to think it does make progress, but I think it's very hard to articulate what that sense is. And I'd be very happy to hear your ideas. Here's some references. Thank you.